Good afternoon, ladies and gentlemen. If you could kindly take your seat, we shall begin in just exactly 1 minute. All right, if you could kindly take your seats. Okay. Welcome to the official side event of the UN Framework Convention on Climate Change, COP27. The title of the side event is Carbon Dioxide Removal as an Ocean Climate Solution, urgently taking a precautionary approach. This event is jointly sponsored by Ocean Conservancy and the Woods Hole Oceanographic Institution. What I propose to do is introduce our panelists first and then turn it over to them with a question, a lead-off question that they can use as they see fit for about 5 to 6 minutes of intervention. We hope to have enough time to have a conversation between you and the panelists on this very important topic. In the nature of introduction, let me just say that the ocean-based climate solutions have gained a great deal of recognition for their mitigation potential. We have here a panel of experts that have looked at this issue from a variety of angles and are willing to share their expertise with us on this important topic. And this includes a range of issues. One is a code of conduct. If you were to do this, how do you go about doing that? And what is the framework, an ethical framework within which activities like this might be carried out? And then, of course, if it all comes through the right way, how do we integrate this topic across the UNFCCC agenda and work programs? The challenge before us is a formidable one. Granted, we made a great deal of progress since the adoption of the Framework Convention on Climate Change in 1992. And that progress is in bringing together all the various stakeholders that are interested in this topic to agree that joint action is vital. But the progress that we cannot be proud of is the fact that every single year, the emissions continue to grow. And to keep the temperature increase to 1.5 degrees Celsius, it is absolutely vital that as we continue accelerating the measures to reduce the greenhouse gas emissions and do everything we possibly can in the countries with mitigation efforts, we need to think about other solutions as well. And this panel's goal is to explore that in some detail. It is always, whenever we have a panel like this, the notes given talk about how to introduce all of our various panelists, but they don't say how I should introduce myself. My name is Ramakrishna. I'm with the Woods Hole Oceanographic Institution. I'm an international lawyer by training and have worked on climate change issues for a long period of time, going all the way back to the drafting of the Framework Convention on Climate Change. To my immediate left is Dr. Ken Buesseler. He's a marine radiochemist and a senior scientist at the Woods Hole Oceanographic Institution. He has been working on the topic and the discussion for at least a couple of decades, if not more, and has a great deal of experience and a string of publications to his credit that have looked at various aspects of this, and I'll come back to him very soon. But the most important thing I want to mention in his introduction is that he was a member of the National Academies of Sciences, Engineering, and Medicine's committee that in 2021 released a research strategy for ocean-based carbon dioxide removal and sequestration. And I'm told that this is one of the most downloaded reports of all of NASEM, National Academy's reports in its history. To my immediate right is Dr. Margaret Leinen, and I want to say, even before saying anything about her, that the Buesseler Oceanographic Institution and the Scripps Institution of Oceanography together have launched the Ocean Pavilion for the first time in the history of climate negotiations, and it is a great pleasure to have her join this panel. She is the 11th director of the Scripps Institution of Oceanography at University of California, San Diego, and serves as the Vice Chancellor of the University for Marine Sciences. She is an award-winning oceanographer and distinguished national and international leader in ocean science, global climate, and environmental issues. Her research on paleoceanography and paleoclimatology focuses on ocean sediments and their relationship to global biogeochemical cycles and the history of Earth's ocean and climate. She has a number of other distinctions, but in the interest of time, I just want to leave it at that. To my far left is Dr. Sarah Cooley. She's the Director of Climate Science at Ocean Conservancy, one of the sponsoring organizations of this side event. She's an ocean carbon cycle scientist by training. I had the opportunity to join her in a lecture to the WHOI MIT doctoral students not long ago, and she really relishes the opportunity to educate audience of all backgrounds, not just doctoral students, about the ocean effects of climate change, and urges them to take evidence-based climate action. And that's a very important point, evidence-based climate action. She was most recently the coordinating lead author on the oceans and coastal ecosystems of the IPCC AR6. To my far right is Dr. Carol Turley. She will be the commentator on the panel. She is head of international office of the Plymouth Marine Laboratories, one of our partners of the Ocean Pavilion. She has contributed extensively to the subject matter, including to IPCC Working Group 2 assessment reports since 2006. She played a leading role in EU, UK-wide ocean and climate research programs and has over 120 peer-reviewed publications. She has contributed to many UN events, including speaking at the UNFCCC Substa and organizing and presenting various meetings on the margins of the various COPs. She received an OBE for services to science in 2011 New Year's Honors List. With those introductions, I want to begin by turning to Ken Buesseler. Ken, as I have said, you have been working on this topic for more than a couple of decades. What really motivates you to work on ocean-based carbon dioxide removal and ocean iron in particular? And as you answer that, please also share with us how your view has changed in this period of time. Did it remain the same, or anything you can add to that? Over to you.
Well, I think this is showing green. Are you hearing me? Okay, I just have to get close. Apologies. Thanks, Rama. When we were thinking about CDR, and I've been working for decades on the biological carbon pump, the ocean role in cycling carbon, and the challenge we've had is just measuring that. What are the impacts? What have been doing it? But I think the opportunities we have are how could we purposely and responsibly alter this to help us get out of this climate crisis. So that's the title on that first slide, which is paraphrasing a bit of why we're here. If we can just flip to the second slide. Oop, there should have been one in between. No, missed. Okay, basically it said, how do we do this in a responsible way? Because it's not just enough to think about scientifically how to get carbon out of the atmosphere and store it in a durable way with transparent technologies to measure those fluxes. We have to do this responsibly, so we will be talking a lot more about that. What I was asked to do is really introduce the topic more and why we're here. So we're going to get a little bit of a lesson here in the ocean carbon cycle. I apologize, many of you probably know this and have worked in this area for decades, but I think it's good to start there and let the other speakers move on to some of the ethical issues. So the next slide we can get to now. Let's hope it's the right one. So that's the first question, right? And I was even asked this just yesterday, you know, why do we need CDR? Is this a get out of jail free card for fossil fuel companies? And the answer is no, right? We need that first blue line, the reductions. We all know that. COP, this whole process is about how we reduce emissions of CO2. The vertical axis is carbon dioxide emissions, and we've got to start down that path. But that blue wedge is really important. It's come out of the studies and the IPCC reports that we require carbon removal as well to keep to these targets 1.5 to 2 degrees Celsius. We're not going to get there just with emissions reductions, which should be doing, we are starting to do, but we also have to consider then carbon removal. Okay, so why is an oceanographer talking about carbon removal? The next slide, please. This really tries to encapsulate what the scale is of the ocean in terms of its storage potential for carbon relative to the atmosphere. That number there in the deep ocean, the big circle, is about 50 times bigger than all of the CO2 and the carbon in the atmosphere. That means if you took all of the fossil fuel emissions since the Industrial Revolution, you would perturb that deep reservoir by less than 1%. It's a big place that naturally stores carbon, and we'll get into how that works in the next couple of slides. So we have to consider this. It's also, I've learned, I guess, over the last few years, comparing it to land-based things like reforestation, that there's 15 to 20 times more carbon in this ocean reservoir than all of the plants and the soils on land. So if we're talking about where we might want to purposely and durably store carbon, you can't ignore the ocean. This is important for us to consider. So how does that get in there? The next slide, please. Again, apologies if you've been studying this as researchers do their whole career on the solubility pump. To general audiences, I say, think of that can of Coca-Cola and it's got the CO2 bubbles in it. You put it out on the bench top and it goes flat, right? That excess carbon dioxide in your soda comes into the atmosphere. Well, this is the reverse. We're putting excess carbon dioxide into the atmosphere, pushing it into the ocean through air-sea gas exchange and the solubility pump. That's what's responsible for about a third of the uptake, or the third of the sequestration, I guess, of the CO2. It's also why we have ocean acidification and other effects in the ocean that I think will be less of a topic here. But important is also that the deeper this goes, this is kind of a long-term global circulation issue of how long will that be stored. There's not a lot of that circulation places where we have deep water formation that would store that for, say, 1,000 years. Most of that can get recycled on short time scales. So solubility pump, probably heard about that. The next slide. This is more of what I do. The biological carbon pump, that's somewhat quicker. It starts with photosynthesis, right? It's the plants, the marine algae in the surface ocean that take up CO2 as they grow, forming organic carbon. If you think of a byproduct of that oxygen, half of the oxygen on this planet comes from that process. These marine, tiny microscopic plants play an important role in the carbon cycle. In terms of storage and climate, though, it's important that what happens after that. That's the arrow into the zooplankton, into the fish, into the larger predators. We have these food webs. They're eating each other, recycling that carbon, some of which sinks down gravitationally settles into the deep sea. And again, those layers we saw on the last slide are the same layers that these sinking puddles get through in days or weeks, not the long-term circulation time of the ocean, but it's very quick process to remove carbon out of the atmosphere into the plants and get it down. And so that's really why we're going to talk a little bit more about how you might perturb that. I'll also point out, someone took a picture of this that says the word poop on there. These particles are basically fecal matter, carcasses, materials produced by that upper ocean food web that are passively settling down, this marine snowfall. Quite an important process, and about 10 gigatons of carbon per year are being removed out of the surface, 10 billion tons. Not all of that gets to the deep ocean. That's why that arrow gets smaller, but that's important. So next slide. I've only got 2 more slides. Someone mentioned, I guess, with the introduction from Rama, that I was fortunate really to be part of a consensus panel looking at several CDR approaches in the ocean and how they might effectively and durably store and remove atmospheric carbon dioxide. So we were assigned our task. COVID had just hit, so this was a challenge to do over Zoom meetings. You can see the key takeaways. I want to, because you probably can't see the ones we considered. On the engineered side, the abiotic, it's alkalinity enhancement and electrochemical shifts to alkalinity as a way to change that solubility pump. On the biological side, it's things like, I'll talk in the next slide, to fertilization of the ocean, enhancing productivity that way, seaweed cultivation, enhancing offshore ecosystems. That's why we use this word deep blue here. We really didn't look at coastal blue carbon, but what the capacity was in the open ocean, and then things like artificial upwelling tubes was the 6th. So the 300 pages distilled here to 1 slide, and was that 7 bullets? Emissions reduction, I'd said that earlier, not enough. We outlined a research program that should be starting now. We need to find support for that. It's not endorsing any one of these 6. In fact, we said we should be doing all of them. It's not just technical feasibility, it's how we use the ocean commons, who governs that, who controls that. Funding will probably come from philanthropies and hopefully government agencies. And I like to tell people, the field studies, people often extrapolate to the billion tons. We're going to start out with 1,000 tons, 10,000 tons, and I really truly believe, and I've done some of those experiments, we're not causing irreparable harm. Let's get on there to get the information to move ahead or not move ahead on any of these 6 technologies, and we need to follow what we'll hear more about are these ethical standards. So the final slide, I just want to give one example of a new report. We'll be handing out postcards with a QR code if you want to download a 20-page report. I've been organizing a group under this title, Exploring Ocean Iron Solutions. That was one of those 6 technologies. I underlined here, exploring. We do not have a solution. And so that's 24 institutions internationally trying to figure out what that next R&D program should look like specifically for this form. So how durable is it? How does it scale? What are the ecological impacts? What are some of the practices that we'll hear about? And so I encourage you, I can't do it justice in 1 slide, but take a look at this and come to our website to learn more about this particular approach to ocean CDR. Thank you.
Thank you very much, Ken. It's very, very helpful to set the stage. And we'll come back to questions after all the presentations have been made, okay? Our next speaker is Dr. Margaret Leinen. Margaret, you're going to speak about all these and some more, but I just want to add one specific question, and that is, we talk about a code of conduct, for ocean-based CDR research and development. What is the value of a code of conduct in terms of both our ability to mobilize the funds necessary, and particularly in getting the public to accept that what we are doing is in the best interest?
Thanks, Rama. For at least a couple of decades, the scientific community has been advocating for research into ideas like this one. This one happens to be an ocean carbon dioxide removal idea, but they've also explored other kinds of ideas. And all of those discussions of exploring ideas and discussions of research have been met with incredible feedback from the scientific community, from government, and from the public, saying, even if you want to think about research, you need to have some assurance for us that that research will be done responsibly and in an open fashion. And so what I'm going to tell you about is a little bit of the history of this, and then some ideas about how we could ensure that ocean carbon dioxide removal, whether it's ocean iron solutions or other ideas, could be conducted responsibly. Next slide. So how do we proceed in a way that assures us that the research will be conducted in a responsible, principled way, but also that it's open and can be evaluated by all? And next slide. So we've struggled with this for about 15 years. And next slide. And this started, this idea of establishing a code of conduct started during the late 2000s when the UK House of Commons conducted an analysis of geoengineering. That was the term that was used then, sometimes called climate engineering, sometimes called climate intervention. And while they were doing that, they were also just talking about this with a group of 5 academics from Oxford. And that group developed what we in the field know as the Oxford Principles for the Governance of Geoengineering, and published that effort in 2009. And the ideas that they have not changed much with time. What has changed is, I would say, the breadth of the inclusion for people in that discussion. So note that this was 5 academics who put this together. Next slide. In 2010, the Climate Response Fund, which I led at the time, sponsored an international conference at Asilomar on principles for research in climate engineering. And this was modeled on a conference that took place about 15 years before that at the Asilomar Conference Center, and it was on recombinant DNA research. And it set the stage for responsible research on what at the time had been an extremely controversial topic. It was led by Paul Berg, a Nobel Prize winner, and he was an advisor to us for Asilomar and or for the conference on climate engineering. And we brought together a group of 172 individuals from science, government, environmental nonprofits, historians, ethics experts, economists, and even the press to discuss this over a period of a week and have discussions about the principles and what would be necessary for people to feel comfortable, whether that was the scientists themselves, the funders of that science, or the public. Next slide. Since then, and I'll say that the Asilomar principles are not very different from the Oxford principles. Since then, the Carnegie Climate Governance Group has issued a code of conduct for responsible geoengineering as part of their governance study. So they were interested in how we would govern and regulate this, but as part of that developed a set of principles. Those two are very similar. And the National Academy, as part of a report on solar geoengineering research and its governance in 2021, developed or referred to principles, and again, not very different. The point has not been that we've discovered something very new, but it's about enlarging the discussion around this. The next slide. And all of these reports emphasize open research, transparency about funding, and discussion between Ken and Rama and I emphasized the Asilomar conference for Ken's particular research objective because it wasn't solely focused on solar radiation management. It was focused on research, not implementation, and it was developed by a large international group of experts in the field. And we published that earlier this year in Nature. Next slide. And these were the principles, and those of you who have followed this field for a while will see that there's, again, not a lot new there. The principles, that first one, that this prioritized collective benefit for humans and the environment, is code for it shouldn't be a commercial endeavor with being able to sell carbon credits from the experiments or other profit motivation. That we needed to establish clear lines of responsibility to oversee the studies. The International Maritime Organization of the UN has had experience with this and has done some of this. There are other possible groups that might oversee and look at this in terms of responsibility and what needs to be done to make people feel comfortable. Third, Ken emphasized openness, that we need to commit to open and cooperative research, including open risk assessments. So having data that allows anyone to see what the impact of the research was in order to assess risk. That the group should perform evaluation and assessment in an iterative and independent manner. And I might say that Ken's group has said that assessing the impact, that is, was carbon sequestered, did ecosystems change, might cost much more than the experiment itself, and that has to be included in the thinking about this. And then finally, that the public must be engaged in consideration of climate intervention options and this kind of research. Next slide. Recently, there is a new effort which takes an even broader and more open approach to engagement on this. The AGU, for those of you who are not familiar with it, is the American Geophysical Union. It's the scientific society that represents most of climate change research. 60,000 members, although its name is American Geophysical Union, it's an international body. And it has undertaken a new effort for looking at climate intervention principles that engages an even broader range of participants, including many who have not been directly part of the discussion before, including many more representatives of the Global South, representatives of climate and environmental justice voices, and that, I think, was not really a part of any of the previous efforts, and representatives of indigenous voices. All of those are at the table. It's a very broad effort to pull together the thinking about this and to set it in that context that includes all of these voices as well as science and government. They included representatives of previous efforts to establish principles and are working on a white paper that will be presented at this year's fall AGU meeting and will be open for comment. So now we've gone from 5 academics through several iterations, including broader groups, to now really a global effort from science, social science, government, voices that haven't been heard before, to again look at this issue of how best to frame this research. And I think that as we do this, we have the best possibility for not only providing input on the research experiment itself, whether it's being done correctly, but also on the assessment of it, just what will be necessary to convince people that carbon has been sequestered, that there are questions about impact on environment, on the ocean environment, on the ecosystem, and issues like the cost are properly assessed. So I think the whole community really welcomes this effort. And I think that's about the last slide. Yes. So we've seen this phrase at the Ocean Pavilion for Our Blue Planet, so I just add ethical CDR research for our planet. Thank you.
Thank you very much, Dr. Leinen. Now let me turn to Dr. Sarah Cooley. You have heard both from Ken and Margaret that though there are scientists, included, a number of social scientists as well. Do you think that kind of an approach is sufficient, or do we need a focused multidisciplinary approach to these topics? And how would you carry that out? And what would the composition do to what we need to accomplish? And then one further question to that, which is that while we agree that these topics deserve all the research funding that is necessary, the same research funding doesn't automatically translate for the multidisciplinary research. Appreciate your views on that.
Sure, thanks. You've given me about 6 questions and I have 5 minutes, so I will be challenged. Next slide, please. I want to dig in a little bit to look at what we know. There is an emerging agreement that we need multidisciplinary research on ocean carbon CDR, or ocean CDR. The National Academy's report did a really nice job evaluating what we know. And I have kind of bucketed that information and kind of remixed it a little bit. And in a product from a number of social scientists and myself, we reviewed kind of how to view what we know in the scope of what we need to know. And so the research that we have that's growing the fastest, or that even is in the earliest days, is primarily in the techno-economic category. So we're looking at things like carbon uptake, the cost of any method, how long carbon is stored by any method, how do we monitor for leakage or for uptake, and how do we verify that that carbon was actually removed? How do we decide, yes, this is additional removal to what would happen with natural, aside from natural processes? That's really where the research is centered right now. There's a little bit more beginning on the environmental and institutional aspects of ocean CDR, and we have the most early research focused on evaluating the fitness of existing policies to address the arising considerations associated with ocean CDR. There's also very early thinking about what policy needs we have in the future, and what might be population and ecosystem scale outcomes from any of these methods. We are still really, on the drawing board thinking about how any of these methods would or could be financed. There are a number of options that are kind of coming together today, really. But a comprehensive look at how any of this might relate to existing methods of climate financing has really yet to be done. And then finally, there's another bucket of topics around social perceptions and ethics, which are essentially, not begun yet. So in our review paper, we kind of took by analogy what we know from other areas and began to think about how might ocean CDR techniques be viewed in terms of their suitability to be undertaken in a particular location, the importance of undertaking ocean CDR versus other activities in the ocean space or activities around climate intervention or even emissions reduction that a community might choose. Also, we really don't know a lot about the governability of any particular method. Really, how would it be implemented? How well would the public believe it could be governed? Then there's also generational implications to any of these things, because we're talking perturbations to a long-term geological cycles, and some of these perturbations might have to be maintained over a long period. So there's really a lot of generational implications, and it really identifies that we really need to broaden our focus from the techno-economic, which is really the primary early movers of research, our focus there, into a more broad, holistic view. And so if you're interested in kind of digging in a little bit more, that annual reviews paper does a much more eloquent job, especially on the social science topics that I raised, than I could. I'm a natural scientist working with social scientists here. Next slide, please. So one of the things that we spent a little time on in this analysis is that ocean CDR research must be precautionary. And we wrote, the philosopher Christian Month summarizes the precautionary approach as requiring that activities that may bring great harm should not be undertaken unless they've been shown not to impose too serious risks. And, it is also, these risks include ecological change and social change. So we need to think about how any of these techniques might interact with communities faced with the loss of their culture. Or what if any of these techniques would interrupt the relationship of a community with the ocean space? Might any of these techniques actually interrupt existing industry and activities that contribute to well-being? Those are some of the things that we need to be thinking about when we're thinking about precautionary research. It's really called for when, the possibility of negative impacts are severe or irreversible. Like research is really needed when those negative impacts are kind of on the table or are potentially going to be irreversible. But really thinking about that broader context is important. And that we see that the precautionary principle is widespread in existing international policy. We're hearing a lot of policymakers, advocate for precaution when we are thinking about carbon removal of all sorts. But it's interesting that in our analysis, we also identified that precautionary principles could be invoked to support CDR given the extreme risks of climate. And so it's really interesting to think about, well, what do we do? What type of precaution are we thinking about here? The conclusion that we kind of identified from the philosophical literature in our review was that there is a reason to pursue carbon removal broadly, not necessarily in the ocean, but broadly, carbon removal, but prefer approaches that are proven to change a carbon cycle, but have non-carbon cycle effects that are either reversible or just benign. And right now, we don't know any of that for ocean CDR. We know almost nothing. So it's kind of like we don't have enough information even to decide whether we're being precautionary. And so, next slide, please. And so one of the first steps actually is to develop an ocean CDR code of conduct. And in a parallel effort and a parallel paper to the one that Margaret and Ken discussed already, I had some colleagues and I from nonprofit organizations put our heads together and compared other codes of conduct. We looked in the biomedical research, in weapons research, we looked in nuclear research, and we really came up with a number of elements that an ocean CDR code of conduct should contain. And we got a little bit detailed. We got to the point you need to have elements for interpretation of the code, recognizing that the writers of the code are not necessarily the people with the same value set as those who could be affected by any of these techniques. There's also principles for responsible research that you would have to inject into that fully detailed code of conduct. And you'd also have to make pretty strong provisions for equity and fairness. And the reason for kind of being so explicit in a code of conduct is that really conducting any of this research in a responsible way really involves inclusion, it involves transparency, it involves sharing the benefits and the risks in an equitable way, and it also involves co-creating the research questions to make sure that the research answers will serve the needs of everyone who has an interest in the ocean. So really an ocean CDR code of conduct has the potential to provide those guardrails for allowing precautionary research that weighs the challenge of the climate crisis against the challenges of intervening in a particular system at a particular scale. And there's a long literature that I don't have time to go into about how to do precautionary research, but really it is, using laboratory results, modeling, assessing. It's a cyclic process with clear off-ramps to the research should any method turn out to be too much of a perturbation or too risky in some other way. So I think that's where we're probably headed with the research, and I look forward to discussing it more. Thank you.
Thank you, Sarah. Our final speaker is Carol Turley. She's going to be commenting on the three presentations, and she's not new to the subject matter. In fact, she has carried out a great deal of research on these topics, so she's going to bring us her own expertise and reflects on the three speakers that just concluded their presentations. Carol.
Thank you very much, Ram, and thank you to the other speakers for allowing me to give this commentary. I just want to define the problem that we have, is that millions and millions of years ago, the ocean phytoplankton bloomed and they fell out onto the sediment bed, and over millions of years they built up. And then more sediment fell on top of them, and then they got squashed, metamorphosed, and laid down in the rocks. And these are what we're using as our fossil fuels. And so millions of years after they were laid down, within 200 years, we have taken those plankton, the carbon from those plankton, we call them fossil fuels, and we burnt them and put them in the atmosphere. Now this is causing the atmosphere to warm, the oceans to warm, and to acidify. And also, because of that, there's oxygen loss and loss of biodiversity and so on. So 30 years ago, science recognized that this was a problem, and we set up the UNFCCC, we set up the IPCC to do assessments on climate change. And we now recognize that we have to reduce those emissions going up there, but we've left it so late that we actually have to do something else. There's Ken's big slug of that extra carbon, that even if we met the Paris Agreement and achieved 1.5 degrees centigrade, we still have to remove carbon. And the question is, where do you put it? Because life on the planet, with that still in the atmosphere, will be a big problem. So the proposal that we're hearing around is that the ocean is quite a good place to put it. Because, to be honest, we've put an awful lot in the ocean. 100 years ago, we were putting our sewage in the ocean, and we realized that was a bit of a problem. So we introduced methods to clean up our sewage. We've dumped pollutants in the ocean and realized that, oh my goodness, we better do something about it. It's impacting the organisms we eat and so on. And so we put in legislation for that. And then we put nuclear waste in the ocean in big barrels and chuck them over into the deep sea. And then the general public, after a while, recognized that that wasn't a good idea either, because the ocean is a big place. It also rusts things and things leak. And so we're back to the question of where do we put this CO2? We can put it in forests and trees and plant like that. We could put it in the ocean, but how do we put it in the ocean? And what are the impacts of that? So the impacts and the risk. So the impacts on if it's going into the deep ocean, the impacts on that amazing ecosystem that we've really only just discovered, that is hugely biodiverse. It also is food limited. So a little bit might be useful, but we don't know. It's the not knowing. By taking out, perhaps by iron fertilization or something like that, or seaweed, by taking out that carbon in a biological form, we're also taking out the nutrients that help fix that carbon. So the phosphorus and the nitrogen that help fix that carbon, and we transport that into the deeper ocean. And by putting the carbon in the deeper ocean, well, they think there are living things down there, and what will they do? They'll break down that carbon. So they'll use oxygen for that. So there's a danger that you may get more deoxygenation. And also they produce CO2. So you're transferring the acidification into the deep ocean. You may also get return of other greenhouse gases, such as nitrous oxide or methane. So there's all these unknowns. And this is why we need research in order to ask those questions. But those questions need to be formed by scientists from every form of life, and not just scientists as well. We need to understand the durability of this. I mean, we're hearing that it could go down. Not all of that carbon that's fixed will get down there. It depends on the size and how quickly it sinks. Some of it will return within days or weeks. So that's a wasted effort. Some will go down into the deep ocean, and it'll depend on the circulation of that ocean. And that could be 100 years or more. But is 100 years, what's going to happen in 100 years? Is that going to come up and be a little bit of a social problem when all this CO2 comes up? We don't know. We have to really, really think carefully of this. And is it scalable, and what scale do you put? Do you want to fill the deep ocean with a big wodge of seaweed in these ocean basins that are going to become anoxic? I don't know. And then is it all verifiable? Is it going to stay down there? If we're going to do carbon credits and people are going to pay for this, will it stay down there? And how long will it stay down there? And then the cost. The environmental cost of mining and doing this and growing this. And, you know, if you've got seaweed farms all over the ocean, you know, is that going to impact transport by sea? Is it going to migratory pathways by organisms and so on? You know, you can just go on and on. And then there's the ethical aspect, it's the interaction with the other ocean activities, and the fact that the ocean moves. It's not sitting there. Things don't go straight down. Things go and they move, and this ocean circulation is what controls our climate and weather. And so it moves around, and what's your ocean one day will be my ocean in 10 years' time. So there's a whole ethical issue here. And liability is an issue too. What happens if it goes wrong? Who pays? You've stolen my nutrients. I have no nutrients for my phytoplankton because you put them all into your macroalgae, which you've dragged out there and sunk. Yes, but I paid you to allow me to sink my macroalgae. You know, there's a whole cycle of biological, physical, and human problems. And of course, there's the whole governance issue that needs to be sorted. And of course, we've got the timing issue. You know, 9 years or so, we'll have reached 1.5 degree centigrade. Now, humans naturally want a rapid fix. I don't think this is the rapid fix. We have to do this ethical research because people will be going out there and offering you carbon credits to go and sink a bit of ocean carbon out there or something. You know, there are people after fast bucks or fixes. And we all want to help. So, and if really good marketing, you know, you'll buy anything, won't you? So I really support a code of conduct for ethical research, because without filling in these unknowns, we will not be able to give a clear response to people that said that. And the thing I'm really afraid of is the unknown unknowns. Thank you.
Thank you, Carol. You have once again stressed how important it is to get what we are doing right, and the various approaches that the previous speakers have talked about, and the importance of those in terms of increasing public's confidence. You have also stressed the potential for it to go sideways, and you know, something that we need to really keep in mind. Now the floor is open. For those of you that have any questions, please raise your hand, and when the microphone comes your way, please identify yourself with your institution. Yes, way at the back and then right in the front. Please keep the question brief and also point out who it is addressed to.
I am Shoma Datta from India, from an organization called MOSM. My question is, in fact, addressed to all of you who are advocating ocean CDR. What happened after LOHAFEX in 2009, which was largely deemed a failure because the supposed carbon dioxide removal didn't happen, only 14-15% happened. And this was done twice. And the second part of the question is, you mentioned specifically that this is not to be connected with carbon markets. But the advisory committees of Article 6, recent recommendation and a recent push for ocean CDR, doesn't these two fall in place? It's like a jigsaw puzzle falling in place, and that gives an indication there is a nexus between the fossil fuel industries and the recent push to take attention away from emission reduction, which is essential. And the last part, you clearly mentioned, which we all know, this is not a quick fix. The IPCC AR6 has clearly given us a deadline that by 2030, if we cannot reduce by 45%, there might not be any possibility of reduction. Then knowing that this is not going to deliver in a very short time, why are we pushing for that? Why are we again going into the carbon market, which actually devastated many of the third world countries? And we have done studies on that, we have done reports on that. Thank you.
Thank you. The right in the front here. Thank you. I'll come back and I will take 3 questions and then we'll come back. Okay? 3 questions and we'll come back.
Yes, fantastic. Thanks so much for this tremendous panel. I'm from the Center for Media and Democracy, USA, following us very closely. I wanted to direct this comment to Dr. Sarah Cooley, who made the fantastic mention of where the precautionary principle could actually really be supporting CDR in that sense. And I wanted to mention that on October 27th, just a couple weeks ago, apropos of that, in Madagascar, you probably are aware of this, because this is the African COP. And what I'm referring to is African nations in the lead for climate solutions. AU organized a meeting where they invited many ministers and top-level people to Madagascar to talk exactly about what it's phrased ocean pasture restoration. It's a form of what you're talking about, where you're actually going to the eddies where the baby fish hopefully will go eat food that currently they're starving because there's no food, so the fish populations are down. These countries are interested in the first step. The second step is CDR removal. The first step is the fish come back. And it's a beautiful thing. And the African countries are really interested in this. And so when the fish come back in large numbers, huge amounts of carbon dioxide is removed from the atmosphere. You get very significant reduction of the greenhouse blanket. And so I wanted to get a little comment on that, but just in the context, when you talk about things like carbon budgets, a little misleading because, as you know, Pakistan would not say we have anything left in a carbon budget. They were flooded because we have enough already in the atmosphere to cause these terrible things. So the point is, CDR is a precautionary principle is saying, yeah, you better start taking it out now. Because even if you had a magic wand and had emissions reduction down to 0 tomorrow morning, Pakistan would still happen with no difference. So if I could get a comment from Sarah Cooley on what's going on in Madagascar in light of what she said.
All right. Questions? Right there. Thank you.
Last question.
Thank you. Great panel. I really appreciate the energy and attention that's gone into this issue following the National Academy study. Oh, Andy Pershing from Climate Central. And what I'm wondering about is, I think, related to one of the previous questions, and that's really what's being done to think about the funding model to actually scale and then operate this. Does it depend on putting a price on carbon, or are there other mechanisms that your institutions are thinking about?
Thank you. Any more questions, or can I go back to the panelists? There is apparently one somewhere there. Yeah, that's two more, and then we'll go back to the panelists. Yes.
Hi, Kostya Tarchenko from University of London. Thanks very much for a very interesting discussion. There is also an approach looking into mineralizing CO2 into a rock permanently, forever. How does this fit into the idea of pumping CO2 under the water? Because that to me seems like a more durable way of decarbonizing. Thank you.
Thank you. And the last question from Lisa Levin from UC San Diego and Scripps Institution.
Thank you. I was wondering whether you have a plan to mobilize the science communities that would need to engage in the many different scientific groups, and including in different parts of the world, and building capacity to do the research that you're talking about.
Thank you. Now let me go back to the panel. Ken, would you like to answer first and go down, or should we start with Sarah? Why don't you start, and then we'll go down the list this way.
Okay, I'll take the question that was addressed to me by name. Thanks for that great question. Yeah, I brought up the point about the precautionary principle to show that it's complicated. You know, precaution is not just like don't hurt the marine ecosystem, because the marine ecosystem is experiencing a climate crisis. The precautionary principle is not a panacea. It's not going to help us, guide us straightforwardly through what we should do. As you pointed out, there are communities looking at restoring, ocean functions that they are lacking, and that's something that is an important community need that needs to be addressed. So that goes back to what I said about the need to co-develop solutions with communities. And one thing that's really relevant that we discovered from our annual reviews, research and review, is that there is almost no public perceptions research that exists for how people view the ocean or view sort of climate intervention outside of North America and EU. There is very little information about how different communities different groups with different value sets view the ocean system, view the urgency of climate intervention, and that research is essential. So I think trying to understand that the most acute needs and priorities of communities around the world is a huge, important first step of the social science research that is needed here. Because until we can all understand, like, what are the global priorities here, and how can we lift all boats by co-developing solutions that suit everyone and address our most urgent crises, we're going to have groups working at cross purposes. So thanks for that great question.
Thank you. Ken?
Thanks, Velma. With 5 questions coming at us, I might have missed a few things. I do want to go back to the very first comment. I think it was about the WHOI experiment. There was iron released, basically unsanctioned, a commercial enterprise promising a certain outcome, a salmon return. And I think that's precisely why we need a code of conduct, because putting that iron in the ocean was not done in an open and transparent way. A lot of these techniques don't take a lot of money. A couple $1 million, you can buy 100 tons of iron, you get a fishing boat, you put it in. And we need these codes of conduct precisely so we can limit that type of activity. We need the R&D so we can kind of have a better idea of at what scale, at what times of year, at what places this would have ecological consequences that are not acceptable or downstream effects that we might want to avoid. So I think that's a good example of why we should be moving ahead. And I think there's a question of, well, who's going to fund that? Is it going to be a price on carbon or something? I think was one of them. I think at this point, we're trying to get ahead, and we might not make it, but ahead of the carbon markets using philanthropic support or federal funding agencies, because at least the way I see it, that's coming. But I think we have to get the science first, and what I've been seeing in some of the commercial markets is a real emphasis on counting carbon only. So if you have a carbon market, that's your commodity, so that's what you measure. I hope what you're hearing is that we're trying to do a more comprehensive view, not just will it work, but what are the consequences to the ecology, to the downstream ecosystems.
Right.
So those are 2 things I could comment on.
Thanks very much, Ken. Margaret?
Address the gentleman's question about looking at ocean iron solutions versus other techniques like alkalinization, et cetera. I think it's a very, very important piece. We're not saying that, or I don't think anybody here is saying that one particular technique is the answer. And the question that Sarah raised in her additional principles about efficiency and cost is a really important one. And any of these things is going to have a complete systems analysis. What is the total cost, not just the cost of the experiment, but the cost of the verification and the cost of any externalities? And I would say that yes, and that technique definitely has to be studied as well, and that for deployment, I agree that it's going to be carbon credits that are going to be sold, but I don't think companies are going to want to pay excess for those, and so I think that will be a big determinant.
Thank you. Carol?
Thank you. There's some great questions there. I just want to talk a little bit about a moral hazard that we have to be aware of, and that is that the risk that CDR, be it on land or the ocean, or especially the ocean, because it could be rapidly quick, the ocean one, it could limit efforts to reduce the CO2 emissions. And I can see some people say, okay, science has solved it, let's shove it all in the oceans and keep on burning fossil fuels. So we have to be really aware of that. And I also want to mention that where all this fossil fuel came from is in geological stores. And around the UK coast, most of those lie under the North Sea. And one thing that we looked at years ago in the 2000s, 5, 6, up to 2010, was the possibility of storing the CO2 where it came from, back in those geological reservoirs, 5, 6 to 800 meters below the seabed, where it's pressurized and solidified, so it stays there. And what our lab did was the scientific investigation over a number of years of what would happen if some of that was released. And this was supported by, it was open, it was transparent, it was all of that. And we even carried out some experiments along our coasts of actually releasing CO2 up through the sediment. And we actually talked to the people around there, educated them and everything. We brought them on side and explained what was happening. And as long as they knew what was happening, it was fine. And so it's really important to involve people at every stage.
Thank you. Thank you very much, Carol. And we have another session that is going to follow immediately after this. But I just want to say a word in concluding this part of it. It's kind of ironic that despite whatever caveats that we place in what we are saying, there seems to be a view that, if you believe that this is a good thing, you think of it as a good thing no matter what. And if you think it is not, it is not. And, but I just want to reinforce the points that are made by the panelists here, one of which is a crucial one. What we are talking about are field experiments, and they will not cause permanent harm, but will help us inform decision makers on the choices we have in front of us for climate solutions. The second is this exercise that we are talking about is in no way an attempt to reduce or replace emission reductions that are vitally needed, and the work that is carrying on, whether it is in the name of nationally determined contributions or otherwise, is a must, and that should continue to be done. And the last point, where all the panelists seem to agree, is that the code of conduct is vital. That will help us in several ways, and then we need to fully benefit from. Already we have seen from 5 to the last slide that Sarah had shown, we have really morphed that into the most comprehensive network that we could possibly have, and we need to rely on that. We need to rely on science to tell us what we need to do, what we can do, because as I mentioned right in the beginning, that the emissions continue to grow, and we cannot continue to let that be the only way of moving forward if you're serious about keeping the temperature increase to 1.5 degrees Celsius. With that, I want you to join me in thanking our panelists, and I would also invite Ana Maria Laura to begin the next part of the segment. Thank you.
Thank you, Rama. And actually, the first panel, if you'd like to stay seated, we'll just invite 2 additional panelists to join you. And that was a great transition. So we've heard from a very distinguished panel here, some of the science driving the conversation around the potential need for ocean CDR and how those different methodologies could work, as well as the need for additional research. So we'd like to invite to join us some of those decision makers or folks who are regularly speaking to those decision makers to the stage. We have with us Eddie Frank Vasquez, who is the advisor to the Vice Minister of Climate Change and Sustainability, the Ministry of Environment from the Dominican Republic. Welcome, Eddie. And we'd also like to invite Sylvie Goyer, who is an advisor to the Vice President of the Prince Albert II of Monaco Foundation. Prior to that, Sylvie was Director of Climate Change and Environment Sustainability Program at the Pacific Community based in New Caledonia from 2015 to 2020. So thank you both for joining us. So this discussion of policy and governance in the context of CDR, responsible research activities should operate under some kind of governance and permitting structure that is transparent, inclusive, and enforceable. There are some small-scale activities occurring near shore now on CDR research, and in those coastal waters, they're in a country's exclusive economic zone. Other, more nascent methodologies may require large-scale, more expansive activity, and they may take place offshore or even further than an EEZ, but in areas beyond national jurisdiction. So in either case, in the coastal waters or far offshore, we often find we have fragmentation in ocean governance. And as you move further and further offshore, that fragmentation can actually turn into a lack of governance and in some things like in areas of the high seas. And this makes it difficult to ensure that responsible ocean-based CDR research could take place and potentially prevent some of those negative externalities, which everyone, of course, would like to avoid. So we have some uncertainty about international mechanisms, agreements, how they would apply to different methodologies. And these unclear frameworks could complicate the process of doing research. And then, of course, if you have research that is successful and we want to move forward from a pilot to implementation, then you're going to need other governance systems that guide that permitting and that implementation. So we really are talking about at least two phases: the research that needs the governance and then potentially implementation. So with that, with the scene set, I'd like to ask Eddie first, from a government perspective. There's a nonprofit operating in Dominican Republic who is looking at ocean alkalinity enhancement, one of the methods that Ken discussed. If you could just talk a little bit about how the government views enabling that research, from your perspective.
One, perfect. So thank you very much for the introduction, and hello to everyone. My name is Eddie, and I work as an advisor of the Ministry of Environment in the Dominican Republic. So as it was mentioned, the Dominican Republic is doing some, let's say, first intervention about ocean CDR, more specifically about coastal mineral weathering with the use of alkalinity addition in some specific coastal communities in the Dominican Republic. So as it was mentioned before, the lack of governance and the fact that the newest technology and the new kind of research and outcomes lead us to new kind of interventions on the ground, that's also a sign of we need to be more prepared for the things that are coming up. For example, in the Dominican Republic right now, the fact that we are leading with public policies, financing, but also social intervention are three of the main areas that we're lacking governance right now, but that the government of the Dominican Republic is trying to work to see how the current public policies can adopt in the implementation of such interventions. So far, when we talk about, for example, going to the communities and intervening in these areas, for us is very necessary to do a bottom-up approach where people and communities are the base of decision-making, as they are the ones knowing the natural resources, and many of the time being the people that counts them accountable for them. Let's say that educating them and putting awareness into them is one of the necessary key instruments that is very crucial for us to make any kind of intervention when we talk about natural resources. It will be very difficult to understand, but Dominican Republic is a small island developing state. And as a small island developing state, many of the, let's say, research that we have done is not centered on ocean development. And that's one of the main concerns that we have as the government of the Dominican Republic when we are trying to develop new governance and policies and legislation that can adopt this kind of intervention on a long-term basis. Speaking on social intervention, I was speaking before about the bottom-up approach, where people is the key of the decision-making processes. But there's many, defining responsibilities is one of the main issues that we have had to lead with this kind of intervention. When I talk about defining responsibilities, there's a lot of different actors that are usually implied into this kind of intervention. We're talking about fishermen communities, we're talking about neighborhood associations, about schools that are usually located in the zones close to the intervention phase. But we're also talking about local municipalities. And sometimes local municipalities has different regimes from the central government, and that makes it a little bit harder to make any kind of intervention without having any kind of duplication of responsibilities as well. So that's something that we are also trying to manage on a very proper way. And the third way will be that this kind of intervention, when we talk about governance, will need to be led by inclusivity, will need to be led by responsiveness. The fact that we are implementing something that, in fact, we know that science is behind it, but there's still a lot of, let's say, side effects that could that could come after the implementation of this kind of solutions, that we have to be such responsive in order to attend people's inquiries, but also any kind of question that they may have before, during, and after the process. So having those different scenarios, preparing the pathway in order to have this on a long-term basis and to make it a common practices in the Dominican Republic are some of the barriers that we are, let's say, facing right now for the implementation of these solutions.
Thank you, Eddie. And you make an excellent point that actually it is not just international, national, it is local governance as well that's going to need to adapt to the research and implementation. Sylvie, same question from both an advisor to a government as well as a foundation that is working on this issue.
Does that work? Yeah, great. I'm very glad to be here on the panel. Thanks a lot for inviting me. And a very critical topic as we move into the negotiations. I'd like to bounce back on some of the comments that Eddie just mentioned from the Dominican Republic in terms of governance. And really, indeed, looking at the two levels, the international and the national. At the international level, as was reminded by Dr. Rama just a little while ago, as you know, if you're coming from the negotiation rooms, there's intense negotiations on Article 6.4. So indeed, anything on trading emissions would have to be firmly rooted in procedures, governance, and regulations in relation to the trading and Article 6.4. This is ongoing. It's not yet resolved, so we need a lot of your effort into it. Also, as was mentioned earlier, an international code of conduct and a governance at the international level, whether within UNFCCC, but also it could be rooted within the BBNG, the UNCLOS, or regional conventions, any of those is appropriate. I'd like to come back to the national and subnational level, if I may, because this is what you've emphasized, and I think this is very pertinent, because it's happening at the local, national scale. So there, and you rightly pointed out to the policies, the regulatory framework that's sometimes insufficient at the national level with gaps and loopholes, and again, a very comprehensive analysis at the national, subnational level of those gaps in policy is critical, in particular when it's about permit issue, and the permit is a big thing, whether it's permit for research in situ work, as we heard, or whether it's about possible deployment. So the permitting issue is quite a critical area with competing jurisdiction across ministries, across different layers. So this is, to me, an important area. The other thing that's interesting on the policy front for governments is how this is reflected in their climate policy. As you know, some countries have gone to even putting a maximum amount of what would be allowed in terms of CDR. We know that some CDR will be necessary to reach the 1.5 scenarios. The IPCC is clear about that. And I apologize, I missed the early start of the session, but I'm sure it's been emphasized. Now the question is, if we do focus on emissions, do we allow some CDR? And if we do allow some CDR into the mix, how much? Do we have to put a limit or not? Is it on opportunity based? Is it on technology based? Is it on financial basis? So this idea and this issue about fitting into the climate policy is, I believe, important in the policy dialogue. And the third point, and I'm very glad you emphasized that from the Dominican Republic, is the whole social acceptance. This is critical. We hear all kind of things. It's you know, this is a new, it's potentially new technology. Some of these CDR measures, like good marine protection, is something we've been doing for years. But some of the new geoengineering is new technology. So what's the social acceptance? And you rightly emphasize that at all levels this is to be inclusive. And I think there are quite a few gaps in the policy dimension that needs to be addressed in terms of public participation, stakeholder acceptance. So I'll conclude right here just to respond to that question. Thank you, Anna Maria.
Thank you. And so building on that, we have recognized now there is sort of gaps in policy, both for research and scale. I'm going to bring Dr. Leinen and Dr. Ramakrishna back into the discussion because I think we have progress being made towards a code of conduct on the science. We have, you all have explained clearly that this research needs to move forward so that we can identify solutions if they're there and understand potential impacts. We certainly can't wait on the policy governance questions either, and our panelists have just raised many. So I won't ask you where to start, like there's one final answer, but what is one way to start? Where should we be? Is it local policies, as Eddie mentioned? Is it the international level? Where should we be starting conversations to make some of these, to make processes that could make some of these decisions that Sylvie and Eddie both raised? And Eddie and Sylvie, please also feel free to answer.
Well, I think that there's a wide variety of CDR techniques and even ocean CDR techniques. And some of the experimentation can take place at the local level, whereas ocean iron fertilization is not in anybody's coastal zone. But I'm aware in the US, for example, of several very small research efforts and efforts to look at things like electrolysis, alkalinization, which would have to be permitted locally or by a regional government like a state. And I think that whether we think that's the rational way forward or not, it's something that's happening. And those individuals are working with local and regional government in the same way that the scientists did with Dominica and the Dominican Republic for what you were doing. And we may learn a lot from that process in terms of how governance would deal with a situation where you had, out of a certain population, you had the 1% who are violently against this no matter what. And how will governance manage that? And I think that there will be a lot of lessons learned at that local level.
Thank you, Anna Marie. I think my answer would be that it is both local and global, or international, as you might call it. The experiments that Ken and Margaret were talking about obviously are site-specific, and and we learn a lot. And supposing they are carried out only in the United States or in some of the Western developed countries, we may not have the kind of confidence level across many other countries. One of the reasons why IPCC has been so successful is its ability to bring scientists from different countries all over the globe, for example, in building an epistemic community of scholarship, shared knowledge that what Sarah is saying from United States and what somebody else might be saying from a developing country, they both are in agreement. They're both working together, producing this. So given the kind of gap in appreciation of the safety issues, we really need to do that as widely as broadly as possible. But at the same time, you cannot wait for all of them to be in place at the same time. You need to begin somewhere, and then, but make sure, as Ken is trying to do with the group that he created, make sure that bring as many from outside as possible. So even if the site is in an industrialized country, all those folks have knowledge about how this is being carried out and what was learned as a result of that.
Sylvie, please.
Great. Rama is giving me a very good introduction. I think I'd like to re-emphasize that, and just 2 words. One is collaboration is happening. There are great institutions working on the science already. So collaboration is key, and collaboration and collaboration. And second is indeed the sharing the lessons learned, sharing the results, making sure we have solid monitoring to ensure durable effects and impacts of those CDR and removal techniques, and really sharing to allow all of the parties at the country or subnational levels to really benefit from that wealth of sharing. Final point is often, it often has to be tailored to the national level. So again, bringing back, the local knowledge and the inclusivity that Eddie rightly pointed out will be key. Thank you.
Great. So Eddie, last word to you as a member of government represented. Lots of places to start the discussions, lots of research to be done. What do you view as the role of government in supporting that research agenda?
Government has the responsibility to create, let's say, enabler conditions for this to happen. And always science should lead the way. And alongside with the responsible policy making, I think we're going to go through our right path, but also taking into consideration which are the implications of always doing this kind of new solutions. Of course, this is not new. But for many of the communities that are on the front line of the natural disaster and are the guardians of the natural resources, this is a new technology. And for them to understand the real implication of this, but also to be engaged in the participation of the whole process is very important. So I think government is a facilitator of this whole process, creating and enabling the path, the necessary path for us to have the conditions to make it possible, but also habilitating the conditions to have necessary research opportunity and innovation mechanisms that allows this to scale under the right circumstances.
Wonderful. Well, on behalf of the Woods Hole Oceanographic Institution and Ocean Conservancy, thank you all for joining us in the side event. And then just join me, please, in thanking all of our panelists today.